All right. So next we're going to go ahead and go over some hypothesis testing examples. I strongly encourage for you to have handout number 24 handy. I'm going to go through these problems with you, and that way you can see exactly how we work through these problems. So, example number 1. The recommended daily allowance of calcium for adults is 800 milligrams. A nutritionist believes that people with incomes below the poverty level average less than the RDA. A random sample of 50 adults with incomes below the poverty level had an average daily calcium intake of 755.3 milligrams with a standard deviation of 239.3 milligrams. Using a significance level of 1%, does the evidence support the nutritionist's belief? All right, so let's go through this. First things first, we're going to identify what is it that it should be, what is it that they think it is, and then what is the data we have to work with. So what that means, the first sentence here says the recommended daily allowance of calcium for adults is 800 milligrams. So we know for our null hypothesis, it's saying mu equals 800. A nutritionist believes that people with incomes below the poverty level average less than, so that's telling you which direction we think this is going. So she believes it's less than the recommended amount. And then it goes on to tell us some information about our data. A random sample of 50 adults, so N equals 50. Of 50 adults with incomes below the poverty level had an average daily calcium intake of 755.3. Now, remember, this is the mean that's coming from our sample. We call that X bar, okay? And a standard deviation of 239.3. And then it goes on to using a significance level of 1%, so that means alpha equals 0.01, does the evidence support the nutritionist's belief? All right, so let's go ahead and work this problem out. Okay, so first step, this is problem number 1. Okay, first step is going to be the null hypothesis, like we said, equals 800. The alternative is mu is less than 800. And alpha here, we were told is 0.01. So let's go back here. Sample size is 50, which means that it's greater than 30. So therefore, we're going to use the Z test statistic. And that's going to be X bar minus mu 0 all over the standard deviation of, all over the standard deviation divided by the square root of n. I can talk. Okay. So we found that our X bar was 755.3. And we're testing it against 800. That's our null hypothesis, right? And that's going to be standard deviation is 239.3, okay, and divided by the square root of 50. Be mindful of the fact, make sure you're putting parentheses around the numerator and the denominator if you're doing this all in one go. Do not round off while you're doing this. Enter it as you see it. So this is going to give me Z is equal to 1 second. Let me recompute that. I entered something incorrectly. 1 second. And that gives me negative 1.3208, but essentially negative 1.32, since that's how high, that's as far as the z-table can really go. Okay, so based on our alternative hypothesis, remember it's mu is less than 800. If you ever forget is less than left tail or right tail, just make a little arrow in there, and it's telling you, hey, I'm pointing to the left. I'm a left tail test. Okay? So, left tail contains our alpha of 0.01. And I need to know what is that critical value that corresponds to that. If you go to your z-table and you look at, the right-hand side, where we have hypothesis testing, critical values. Here we've got alpha 0.01. This is a left tail test. So we know that negative 2.33 will be our critical value we're going to test against. With me? All right. So now for step 5, I'm going to take negative 1.32 and see where does it fall in comparison to negative 2.33. So it's centered at 0, and negative 1.32 will fall right there, somewhere around there, okay? So as we can see, it doesn't fall in the shaded region or the rejection region, okay? So our conclusion will be at 1% level of significance, we fail to reject the null hypothesis. All right, so let's look at part 6. That's where we're doing the p-value test. Remember, if p is less than or equal to alpha, and the logic there is if p is even smaller than our alpha, which is pretty small to begin with, agreed? If our probability of finding a sample such as this, if that null hypothesis is true, if finding this sample is even smaller than our alpha, well, we may have reason to reject the null hypothesis. Are you with me? Okay, so we're going to go back to the z-table and we're going to look up our test statistic, negative 1.32. Okay, so when we do that, negative 1.32 is going to be right here, 0.0934. Okay, 0.0934. So that's my p-value. And then my alpha here is 0.01. When we compare our p to our alpha, well, p is greater than alpha. So in this case, we should have failed to reject the null hypothesis. And guess what? We did. Okay? So that confirms. All right. Let's go on. Let's try another problem. Let's make sure you got the hang of this, okay? So we'll go on to number 2. A vending machine is supposed to put 8 ounces of coffee into the cup on the average. So mu should equal 8 ounces. A random sample of 100 cups, that's n equals 100, yielded a mean of 7.69 and a standard deviation of 1.26. So if we let alpha equal 0.05, can we conclude that the machine is improperly calibrated? Improperly. Now, it doesn't tell us it's pouring less than or it's pouring more than. It's just saying it's not pouring what it's supposed to. Does that make sense? Okay. So let's go ahead and write this up. Oops. All right. So our null hypothesis is mu equals 8. The alternative is mu does not equal 8, right? That's what improperly cues us at. Alpha equals 0.05. Test statistic is Z because we have a sample size of 100, which is greater than 30. Okay? So x bar is 7.69. Standard deviation is 1.26. So we write that as x bar minus mu 0. So that's 7.69 minus 8 all over 1.26 divided by the square root of 100. And that will be negative 2.4603. And so once again, we're going to look at our alternative. And well, it's not indicating left or right. Remember, it's a two-tailed test. So we're going to do this. And now, since we have two tails, it's going to take our alpha of 0.05 and split it evenly between the two. So 0.05 divided by 2 will give us 0.025. I'm going to go back to the z table. I'm going to look up alpha 0.05 and two-tailed test. So 0.05, two-tailed test, that gives us positive negative 1.96. So for step 5, I'm going to go ahead and show that I'm comparing my test statistic to my rejection region. And negative 2.46 by comparison falls here in the rejection region. So therefore, we must reject. Okay? Or an easy way to remember this, shaded region, shady friends, right? We reject them. All right? Just a silly way to remember things. So at 5% level of significance, we have sufficient evidence to reject the null hypothesis. All right, step 6. Now we're going to take our test statistic of negative 2.46. We're going to go back and we're going to look that up on the z table. And so negative 2.46 gives me 0.0069. But now be careful, because this is a two-tailed test, make sure that you are mindful that because it's a two-tailed test, it's going to be 2 times that p-value, okay, to account for the fact that we split up our alpha into 2. So this will give us 0.0138. Okay, so compared to our alpha of 0.05, p is less than our alpha, so therefore that confirms we should have rejected the null hypothesis, and we did. Make sense? All right. Let's look at number 3. A normal white blood count is assumed to be approximately 8,000 cells per cc of blood. Okay, so that's what it's supposed to be. A random sample of 15 employees, okay, of a nuclear plant yielded a mean white count of 7.81 and with a standard deviation of 0.872. Is there significant evidence that the mean white count is lower for plant employees using alpha equal to 0.05? Well, lower indicates our alternative is mu is less than 8. Agreed? And alpha is given to us as 0.05. So let's go ahead and write this up. So we said that the null hypothesis is mu equals 8. Based on the language of the question, mu is less than 8. Alpha we were given as 0.05. Step 3, test statistic. Test statistic is t, which is x bar minus mu 0, all over s divided by the square root of n. So x bar was 7.81, and standard deviation is 0.872, okay? So that's going to be 7.81 minus 8 all over 0.872 divided by the square root of 15, okay? And remember, this is t because we have a sample size that's less than or equal to 30, okay? So don't forget that. All right, so when we compute this, we get negative 0.8439. So now rejection region, remember, based on our alternative hypothesis, it's a left tail test where 0.05 is in the left tail. Now, to find this critical value, we're going to go to the t-table. We're going to look up degrees of freedom, 14, since our sample size is 15, 0.05. So when we do that, we get 14.05 gives me 1.761. But I know that this is centered at 0, so to the left of it, I have a negative value. Are we all together? Okay, for step 5, I'm going to compare to see where does my test statistic fall. Well, this is my test statistic. And so, because it doesn't fall in the shaded region, we fail to reject the null hypothesis. So at 5% level of significance, we fail to reject the null hypothesis. Now, for the t-table, it's going to be a little different when we do our p-values, so stay with me, okay? Our test statistic here is negative 0.84. And so I'm going to go to the t-table, and I'm going to look at degrees of freedom 14, and I'm going to look at where does negative 0.84 or 0.84, where does it fall? Well, we see that it falls between these two values. Agreed? So when we go up, we see that our p-value is between 0.20 and 0.25. So p is between 0.20 and 0.25. So alpha is equal to 0.05. So when our probability is somewhere between 20 and 25%, well, it's greater than our alpha, which is 5%. And so we fail to reject the null hypothesis. If you find yourself having a hard time flipping those numbers around, you're always welcome to write it this way as well. And just be mindful of the fact that p is a number that's greater than 20%, smaller than 25%. Okay? All right. Let's do one more example and then you're good to go on labs 16 through 18. All right. Example number 4. A pill is supposed to contain 20 milligrams of phenobarbital. So mu should equal 20. A random sample of 29 pills. N equals 29, which means we're dealing with a t-test statistic because it's a small sample. Yielded a mean of 20.5, so that's x bar equals 20.5. and a standard deviation of 1.5. So test using alpha equal to 0.10 whether the true mean amount per pill is 20 milligrams. Okay, so we're going to go ahead and, okay, we'll write it up. But now where it says whether the true mean, it's not saying it's too high or it's too low. It's just saying, well, is 20 it? So it's not giving you a direction. Does that make sense? So therefore, it would be not equal to. So let's start with writing our, let's write our hypotheses down. So, null hypothesis, mu equals 20. Alternative, we don't know. Is it 20? That's what we're asking. So not equal to. Alpha equal to 0.10. And now we need to compute our test statistic. T, so I'm going to go back here. And so I see X bar is 20.5. So X bar minus mu 0. So that's 20.5 minus 20 all over 1.5 divided by the square root of 29. So let's go ahead and compute that. And we get 1.7951. All right. So left tail, right tail, two tail. So that's going to be 0.05. And so we're going to go back to the T table to figure that out. What does that rejection region look like? So once again, I'm going to look at the T table. Degrees of freedom here will be 28 for n minus 1, 0.05. And when I look that up, I get 28, 0.05, that's 1.701. So that's going to be negative 1.701 and positive 1.701. And when I compare my test statistic with my rejection region, I'm going to show with a dot, this is where it falls. So at 10% level of significance, we have sufficient evidence to reject the null hypotheses. All right. So last but not least, let's go and do the p-value test. So we're looking at degrees of freedom 28, and we're looking up 1.7951. So 28, 1.7951 falls between these two. And when we go up, we show that p falls between 0.025 and 0.05. So we're going to write that as it is. But be mindful of the fact this is a two-tail test, and because that alpha was split in two, we want to multiply our p by 2 when we're comparing by the whole alpha. So that's going to be p is somewhere between 5 and 10%, so alpha is 0.10, so less than, reject the null hypothesis. Okay, and that confirms and confirms, and we're good to go. All right, I'm going to go ahead and put up a video as well for you to do the suggested homework problems for this material as well. I strongly recommend you do those on your own. You watch the video as well, and let me know. I'm here to answer your questions. Have a good day, everyone.